Oxygen is essential for humans to survive, and our atmosphere is made up of 78.09% nitrogen, 20.95% oxygen, 0.93% argon, and 0.039% carbon dioxide by volume. The human respiratory system extracts the oxygen from the air and in return expels carbon dioxide. However, it is not a direct exchange of oxygen for carbon dioxide. We still breathe out around 15 to 18% oxygen, along with the expelled carbon dioxide. The exact amount is dependent upon your fitness levels and amount of energy expenditure. Oxygen is taken into the lungs, where it is passed into the pulmonary capillaries. From there, the oxygen is transported via the bloodstream to the vital organs and in particular the brain. The human body does not store oxygen well, and if oxygen intake, in other words breathing, stops for more than a minute, this leads to a lack of oxygen in the blood. Brain damage can occur after only 3 minutes without oxygen. As part of your role as the AGT, you may be asked to carry out tests to ensure that the atmosphere at the worksite is clear of any toxic gases. Therefore, understanding what these gases may be and their effects on the human body is vital in your role. As the AGT, you should have a good knowledge of workplace exposure levels, WELs. WELs are occupational exposure limits and are set in order to help protect the health of workers from hazardous substances. WELs are concentrations of hazardous substances in the air, averaged over a specified period of time, referred to as a time-weighted average, TWA. 2 time periods are used: long-term, 8 hours, and short-term, 15 minutes. In the UK, the HSE guidance document, EH40, details the WELs for each hazardous substance. Where workers are exposed to toxic gases, these must be monitored. For example, the WEL for hydrogen sulfide is 5 ppm for an 8-hour TWA and 10 ppm for a 15-minute TWA. In the USA, OSHA has similar standards. Please ensure that you are familiar with the workplace exposure limits in the country you are operating in. Let's look at some of the toxic gases that you are likely to encounter in this industry. Hydrogen sulfide, commonly known as H2S, is a very hazardous and toxic gas. Can you think of any of the characteristics of H2S? Type in your answer and then select the Submit button. Can you think of any of the characteristics of H2S? H2S is colorless. It is flammable and burns with a blue flame, and it has a distinct odor of rotten eggs at low concentrations. H2S is highly toxic, and in concentrations of over 30 parts per million, ppm, the odor of rotten egg fades. Why does the odor fade at higher concentrations? Type in your answer and then select the Submit button. Why does the odor fade at higher concentrations? At concentrations above 100 ppm, your ability to detect the gas is affected by the rapid paralysis of the olfactory nerves in the nose, leading to a loss of your sense of smell. This means that the gas can be present at dangerously high concentrations, yet there is no perceivable odor. H2S affects the ability of blood to carry oxygen around the body, including the brain, and causes serious respiratory problems. Let's examine some of the symptoms of H2S poisoning. 0 to 10 ppm, irritation of the eyes, nose and throat. 10 to 50 ppm, headache, dizziness, nausea and vomiting, coughing and breathing difficulties. 50 to 200 ppm, severe respiratory tract irritation, eye irritation, or acute conjunctivitis, shock, convulsions, coma, and possible death. The explosive envelope of H2S ranges from 4.3% to 46% by volume in air. If there is a possibility of H2S being present whilst carrying out gas testing, a full risk assessment must be carried out, and safety precautions such as personal respiratory protection, harness and buddy line may be required. Exposure limits of H2S are covered by different regulations in different countries. But as a general rule of thumb, the Long-term exposure limit is 8 hours at 5 ppm. The short-term exposure limit is 15 minutes at 10 ppm. Always check the H2S exposure limits of the country that you are working in. Remember, H2S is highly toxic, and exposure to it can be fatal. Carbon monoxide, commonly known as CO, is a colourless, odourless and tasteless gas, which is slightly lighter than air. Where can you find carbon monoxide? Type in your answer and then select the Submit button. Where can you find carbon monoxide? Carbon monoxide is often formed during combustion in diesel and petrol engine exhausts. Boiler flues are also areas where carbon monoxide may be present. Carbon monoxide can be toxic to humans. When encountered in higher concentrations of over 100 ppm, it combines with the hemoglobin in the bloodstream and blocks the amount of oxygen which is carried around the body to the vital organs. Symptoms of carbon monoxide poisoning include headaches, nausea, vomiting, dizziness, fatigue, and a feeling of weakness. There can also be signs of confusion and disorientation. You may find that part of your processing operation produces sulfur dioxide. Can you think of any of the characteristics of sulfur dioxide? Type in your answer and then select the Submit button. Sulfur dioxide is a colourless gas which is heavier than air. Inhaling sulfur dioxide can cause breathing difficulties, respiratory disease, and in high levels, death. As a general rule of thumb, the long-term exposure limit for sulfur dioxide is 8 hours at 0.5 ppm. The short-term exposure limit is 15 minutes at 1 ppm. However, always check the recommendations for sulfur dioxide exposure limits for the country that you are working in. Let's try an exercise to test your understanding of the effects that toxic gases can have on the human body. On screen are icons that represent various toxic gases. Select the gas that is colourless, is flammable, and burns with a blue flame. When you're happy with your answer, select the Submit button. Well done! That's correct!